types of problems that we want to look at are going to be rate problems. And you've already dealt with a type of rate so far, and that was distance is equal to rate times time. And we said if you look at units, distance such as miles, rate would be your speed, which is miles per hour. And if you take that times your time in hours, your units agree with each other, and that's how you get distance equals rate times time. Now that can be rearranged in different formats. You could say rate is distance divided by time, but people don't like division very well, so we set it up as a multiplication problem. But other types of rates that you can have is that if I take my rate and I take it times my time, we end up with something besides distance. We could say it's the amount of work that can be done. And another way to look at it is if you have two people working, the rate times the time of one individual, that's how much work one individual can do. And if I add to it the rate times the time of the second individual, so the work of one individual plus the work of the second individual, that's just going to give you the overall work that can be done. If you're talking about a job that involves multiple people. We can work with another type of rate equation where it deals with number. So the number of jobs or the amount of work can be equal to number times rate times time. That's another type of rate equation that we can have. So there's multiple rate equations that we can be working with and that you will be using throughout examples or story problems in this lesson. You are familiar with those right there. This is just an extension of it, but the number times rate times time is just a little bit different. So let's look at some examples of where we actually apply that information. Let me see if I can shrink this just a little bit so I have a little bit of room to work. I don't know if that did much. Joe Frank can wash 3 cars in 5 hours, and Merle can wash 4 cars in 3 hours. 15 cars need to be washed if Joe Frank works for 2 hours and then is joined by Merle. How long did Merle and Joe Frank have to work together to finish washing the cars? So this appears to be 2 people working, correct? So if I look at the possible setup of equation that I might need, it would be the rate of Joe Frank times the time of Joe Frank is going to tell you how much work Joe does. And I want to add to it how much work Merle can do. So the rate of Merle times the time of Merle is how much work Merle does. And that's going to give us the overall work that needs to be completed. So we have to go through and look at the pieces of information that's given to us. Joe Frank can wash 3 cars in 5 hours. You're going to get to the point where if you, what information is given to you there? Correct. And if I want to look at it, I can sit here and just say, oh, here's Joe. And Joe, I have work equals rate times time. How much work does he do? 3 cars. You don't know his rate, but you know he does it in 5 hours. So what is his rate? 3/5, 3/5. You're going to get to the point where you can do that without having to set this up right here. So what I know is I know Joe's rate. Joe's rate is 3 cars in 5 hours. Along the same lines, can you tell me Merle's rate? 4/3. Because Merle can wash, and I should just keep these all the same so I don't have to keep clicking. Merle can wash 4 cars in 3 hours. But I have this next part here that says I've got these 15 cars need to be washed. What piece of information is that? The W. It's the total amount of work that the 2 of them need to get done. And I could determine how long is it going to take Joe to wash those cars by himself. If he can wash 3 cars in 5 hours, it'll take him 25 hours to wash 15 cars. If I look at Merle, if he can wash 4 cars in 3 hours, how long is it going to take him? Yeah, 4 doesn't go into 15 very well, does it? So it's going to be not quite 12 hours. But what if they work together? How am I going to set up that? If they work together from the very, very beginning, the times of the two would just be T, right? They worked for the same amount of time. But that's not what they did, because Joe Frank works for 2 hours and then is joined. Here's where you got to be careful. One person is going to have to be T, and the other one is going to have to involve that 2 hours. The two different things we could do is, if I let Joe Frank be T, then what is Merle's time? T minus 2. This would be T minus 2. When I solve for T, what am I finding? How long Joe worked. What do we want to find out? How long they worked together. So if you find T in this case, you're going to have to subtract 2 to find out how long they worked together, because they worked together for Merle's full time of work, right? Or you could solve it this way. Or we can go back through and since I want to know how long they worked together, the time they work together is the full time that Merle works. What do you know about Joe's time? T plus 2, because he started 2 hours before that. So my equation, this first part right here, is going to tell you how much work Joe gets done. And the second part is going to tell you how much work Merle does. And together, they have to get those 15 cars done. So now I have one equation right here. This equation of 3/5 times quantity T plus 2 plus 4/3 T equals 15. One equation, one unknown value. Can I solve from there? Yeah. Maybe not very pretty because we have fractions involved. But that's okay. Distributive property. So you're going to have 3/5 T plus 6/5 plus 4/3 T equals 15. Do you want to get rid of the fractions, or would you just use your calculator? Get rid of the fractions? I don't like those two colors together when I work through it. All right, to get rid of the fractions, what are we going to have to multiply by? 15. Distributive property means I need to multiply each term times 15. All right, 5 goes into 15 3 times, and you end up with 9T plus 5 goes into 15 3 times, which leaves you with 18, plus 3 goes into 15 5 times, so you get 20T equals 15 squared, 225. You don't like that large, you can work with fractions if you want, I don't care. So you get 29T equals, and if I subtract 18, 207. So as a final step, divide by 29, and T is equal to 7 point something. 7.14. You know what they leave their answer in? I was just checking. They leave it like this. 207 over 29 hours. Oh. What'd you say, 7.4? We'll just do approximately. Is that rounded? 1/4. 7.14 hours. Now, if you wanted to, you could figure out 1/4 of an hour and figure out how many minutes that is. Do you know how you would do that? You would do 0.14 hours. Dang it, sorry. You'd have 0.14 hours, and you would say that there's 60 minutes in 1 hour. What do you get when you multiply that? 8.4. So it's going to take something like 7 hours and 8 minutes. 7 hours and 8.5 minutes. I mean, you could keep changing it so that it means something to you. You could take the 0.4 minutes and change it into seconds if you wanted to. But they just left it as this fraction over here. They just said it was 207/29 hours. Do I have a ice water? I did have, yes, I do. Now he will leave you alone. Now that you have do you like how they did that? Okay, questions? You ready for another one? Now keep in mind, if you would have switched your t's around on that last example, if you would have switched your t's around on that last example, you would have had to subtract 2 from it, because you would have ended up with like 9.14. Is it a fly or a little gnat, or what is it? It's a fly. I haven't seen him yet. I just see Riley swatting. Oh, I saw him. I just caught a glimpse of him. Are you ready for another one? Okay, this one's going to be kind of one that's important that you might see again. Emerson can dig 2 holes in 3 hours. Oh, do you just want to work through it? Okay. I'll let you at least set it up first. I'll give you a minute to set it up. Jade, how did you set it up?
I had 2/3 T plus 1. So I guess that'd be 2/3.
Oh, T plus 1?
Yeah, 2/3.
2/3 times the quantity T plus 1? All right, gotcha.
Plus 3.5 T.
Do you agree with this setup? Oh, because they dig 6 holes need to be done. Otherwise, you got everything else. Emerson digs for an hour first by themselves, but they want to know how long they work together. All right, so finish solving the problem. (32/13 hours? Between what? 2 and 3, closer to? So right around 2.5 hours. Very close to it. So very close, probably around 25 minutes, something like that. Okay. Question on that one? Did good? We are going to stop right now for today.